Hi, I am Arun. I am working as a MATLAB programmer in Spiro Solutions Private Limited. Now I am going to explain the project an automatic graph-based approach for artery vein classification in retinal images. The classification of retinal vessels into artery or vein is an important phase for automating the detection of vascular changes and for the calculation of characteristic signs associated with several systematic diseases such as diabetes, hypertension and other cardiovascular conditions. Our paper presents an automatic approach for artery vein classification based on analysis of graph extracted from retinal vasculature. The proposed method classifies the entire vascular tree, deciding the type of each insertion point and assigning one of two labels to each vessel segment. The final classification of a vessel segment as artery vein is performed through the combination of graph-based labeling result with a set of intensity features. This is an existing system. In the existing systems, they used support vector machines and neural networks to classify the retinal vessels, but it is not that much efficient. An automatic method for classifying the retinal vessels into artery and veins using image features and classifiers are also used. The drawbacks in the existing systems. Automated classification of retinal vessels into arteries and veins has received limited attention and is still an open task in a retinal image analysis field. Vessel calibers can be affected by diseases. Therefore, it is not a reliable feature for artery vein classification. This is our proposed system. We propose graph-based method for automatic artery vein classification. A graph-based approach where we mostly focus on characteristic of retinal vessel tree that at least in the region near the optic disc veins rarely cross veins and arteries rarely cross arteries. Based on this assumption, we may define the different types of intersection points. This is the comparison of the existing and proposed system. As I already told, this is the algorithm definition of existing and the proposed system. In the existing system, the clustering approach divides the retinal image into 4 quadrants, but our proposed system, the graph extracted from the segmental retinal vasculature is analyzed to decide on the type of insertion points, and afterwards one of the 2 labels is assigned to each vessel segment. The drawbacks in the existing system are the classification is propagated outside this zone where little or no information is available. But the advantage in our proposed system is the artery and veins information extracted from graph which represent the vascular network, and it gives the high accuracies. This is the block diagram of our project. We have to get the input image of the eye, it means retina, and then we have to generate a graph based on a vessel segmentation and graph modifications, and then the generated graph is given to the node type decision, and also the vessel center line extraction is given to the vessel caliber estimation. Here we are implementing in some algorithms which is totally named as graph analysis, and then the output from it is given to the future extraction and linear classifier and artery vein classes assessing. These are all belongs to artery vein classification. In this classification part, it classifies which is the artery and which is the vein in the retina. Finally, the classification result will be provided. The proposed system advantages. While most of the previous methods mainly use intensity features for discriminating between arteries and veins, our method uses additional information extracted from graph which represent the vascular network. The requirement for our project is MATLAB 7.14 version or 2028. This is the future system we are going to do. The vessel segmentation of retinal eye is based on threshold selection and the reducing complexity neglect angles between the links of the image. The center line extraction is based on morphological operations such as dilute and erosions. The future algorithms are named as threshold based vessel segmentation and morphological operations.